and to present your talk on responsibilities of military AI in surveillance and reconnaissance. Michael Teutsch is an AI strategist and leader of HENSOLDT in Germany. He has a Ph.D. in computer science from the Karlsruhe Institute of Technology, and he has worked as a research scientist and a postdoc at the Fraunhofer IOSB in Karlsruhe, in Germany. Since 2016, has been with HENSOLDT, the global leader in sensor solutions for defense and security applications. And as AI lead, he oversees the company AI strategy and implementation of AI functions in HENSOLDT's productive performance. So we are anxious to listen to you. Michael, please, the floor is yours. Thank you very much.
Fantastic. Thank you very much for the introduction. And I now try to share my slides. Give me a second. As I mentioned earlier, I'm not super experienced in Zoom. Well, I do see that you are blocking sharing the screens as an administrator of this meeting. Kindly ask you to allow me to share the slides. In the meantime, I can just like a slide to introduce maybe our company just briefly. I mean, I'm an industry representative here today, and HENSOLDT is a German company in the defense industry that is, well, we have been, for many years, we have been a sensor manufacturer, a sensor producer for electro-optic sensors, for example, for radars, for electronic warfare sensors. And we're now in a transition more from hardware focused business to a hardware enabled but software driven business, which means that specifically AI plays a big role in our strategy, but also in our transition. So we're developing a lot of software, we're developing a lot of AI functions that enable us and the users of our products to produce raw or processed data rather than just using sensors. So we are providing data nowadays that can be used for situational awareness, for surveillance, for reconnaissance operations, and the like. And we are active in all the domains, in the military domains like sea, air, and ground, for example. And well, I can now share the slides, perfect. My presentation now will focus on a specific topic that we have been working on together with actually my former institute with Fraunhofer IOSB in Karlsruhe for over a year. And we just like early this year, we published a white paper that is kind of summarizing our key findings of this study. This will be the core of my presentation today. Just asking, can you see the slides?
Yes, perfect.
Great. As I mentioned, I'm an industry representative, so my goal will be also to focus not so much on theory, but rather on applications. So we want to focus when talking about ethics in AI. We want to focus on, well, since I mentioned we deploy and implement AI functionality for automation of data processing into our sensors, making them become smart. But at the same time, we also want to follow ethical principles to enable the user to comply with certain regulations, to provide transparency of the AI decision recommendations to the user, so that he, as a human in the loop, can still act in a responsible way, and in a governable way, for example. But we will see a bit more on this topic later in this talk. I want to start with the motivation and thinking about, I wasn't fully sure about how to start this talk, motivating for the topic of ethics in military AI. And when I thought about that, I remembered a video that I saw a few years ago, maybe 2 or 3 years ago, that was published by an armament producer, by a producer of weaponry, where they showed a kind of a feasibility study that was not like super convincing from the operational use from an operational point of view. So we will now have a look at this video. I hope that you can see it properly. And what we can see here, I want to close down the sound. What you can see here is like an automatic weapon system that is detecting humans in this case and immediately shooting them. And I do believe talking with Europeans, with our European virtues and values, this is something that we would like to avoid specific. And this is just a case study, this is just like a feasibility study, but still, I do not want to see such kind of technology in an operational deployment. So that's, I do believe that this is quite, at least for me, it's a good motivation to say why we need to talk about ethics in AI. So talking about our study and our white paper that we recently published. Before we start talking about specific use cases and how to apply ethics in products or in operations, I just want to give a little overview of the literature that we reviewed before we started with our work. So we had at that point in time, we started our work in late 2023, I think. And at that point in time, we had related work from the US Department of Defense, the DoD. We had related work from the UK Defense Science and Technology Lab, the DSTL, and we had related work from the NATO. And what I just listed here are the principles that they derived in their studies that need to be considered and focused on when talking about the use of AI in military operations. Just by the way, I skipped all the discussions on ethics in AI that happened before, because originally, I think it started in 2019 when companies like Microsoft and IBM were starting a kind of initiative that was called FATE, with F for fair, A for accountable, T for transparency, and E for ethics. And this kind of started all the discussion about ethics in AI, but this is quite generic and this is for civil use, so that's why I directly delved into the military topics and not spending too much time on the theory. What we can see here are a list of principles that are way more described and discussed in the sources that are also added here. So this is where these principles are coming from. Basically what they mean, I just start with this left column and I will just go through this left column, means that the responsibility means that the user needs to be well trained and he needs to understand the system that he's operating with and to understand how he can interact and to act responsibly. Equitable means that he needs to know about how to work fair with the system, how to make, how to not cause unintended harm, for example, to individuals. Traceable means that we want to have some kind of, we want to understand what kind of way was taken through the workflow or kind of logging information to understand like what happened from, for example, the first detection or something in a reconnaissance task until the final report, for example. And reliable obviously means that an AI system has to work reliably without errors, without any it needs to be safe and related things. And it needs to be governable. That means that the user has to be able to override recommendations to change them as he or she needs to do that when acting responsibly and following guidelines and ethics. And I will not go through all these other principles, but what we can see is that they are quite well interconnected, which is not surprising because, well, actually we are talking about Western countries with similar virtues and values, and we can see that those studies are kind of converging to similar topics, which is okay. So when we were doing our study and writing our white paper, we wanted to specifically focus on topics that have not been covered there. First, we discuss these principles and we derive our own set of principles, but we do not reinvent the wheel here. So we can see that the principles that we derived are strongly influenced by what we saw on the previous slide. The only thing that I highlighted that a bit is that we also added the principle of proportionality. And proportionality is something that originates from the just war theory, an ancient theory, actually originating from the Roman literature. And specifically in Germany, we consider this aspect of proportionality is a very important one. What does it mean? It means that when acting with countermeasures, for example, those countermeasures need to be not unnecessarily brutal, for example, or violent, but they need to be proportional in a way that it is kind of an equal countermeasure, so that it's not exaggerating in what we do. And this is something that we can consider as a German principle, but I also consider it as a European principle, I would say, not only because it originates from the Roman, ancient Roman theory and literature. However, our white paper goes beyond that, because what we saw is that most of these papers that I cited before and discussed before, they do not really go deep into how to implement and apply those principles. They just derive those principles, discuss them, of course, from a theoretical point of view, which is fine, which is important. However, when we read the papers, we thought about, okay, what does it mean? How can we implement such principles to make them really become part of the regular workflows of operators when they are working with our products, for example? So what we did is we spent quite a lot of time in defining and analyzing realistic use cases that we call scenarios in the paper. And the 3 use cases that we used to show the application of ethical principles, this will be the core of my presentation today. We also provide a technical point of view for each of the scenarios, which shows the feasibility and the current state of the art from a technical point of view, which means we have a look at what kind of methods do we have out there in the literature that could enable us to do what we are presenting here. And we also provide a discussion on how these 5 principles that we see here on the left are applied to what happens in the use case and in the scenarios. So this is the core idea of the paper, to see it from a more applied point of view. That's why I called my presentation today Ethics in Action. So let's start with those scenarios. So the first scenario is coming from maritime surveillance, specifically from a submarine. We assume that we have a submarine that is trying to observe and to monitor its surrounding environment. And by doing so, it usually highlights all the detected objects to the user. So here is like a mock-up of a graphical user interface, yeah. And we want to understand if there is a potential threat observed by the periscope of the submarine. So we have here like a list of certain capabilities that this AI assistance system for the operator has, like things like object detection, tracking, threat analysis. We have sensor resource management, and we have automation in a way like that certain steps are automated, and but we still consider and enforce the human in the loop. And we also have parallel tasks going on. Having now a look at what happens in detail is in the specific use case. We observe the environment. We see certain objects that are not of interest because they're civil objects. They're not directly heading towards us, for example. But what we see is that we see one object that is directly heading towards us. And this is happening not in a quite high distance. So it's quite, quite well approaching our submarine. So it poses a certain threat. And additionally, we are informed by the AI assistance system that the system is not sure about the class, the categorization of this object. It could be a civil boat. It could also be a military vessel. And here we can see that the confidence is quite similar. So it is uncertain, but it shows this uncertainty to us in a way that it's being transparent to us. And it even provides some information on what could happen if, for example, we do not react, or if we react in a not proportional way, for example. Yeah. So what happens is the user can now click on this analyze button, and what is now provided is an explainable AI method that is quite well known in computer vision, which highlights the regions of the image that contributed most to the decision of the AI assistance system. So this means that here in this example, we have on the right, we have this is the same object, but this is the object seen from the perspective that we assume it is a civil boat, a fishing boat. And here we see highlighted regions that seem to look like a fishing boat to the AI system. And here on the left, we see the same object, and we see highlighted the region in the image that contributed most to the assumption that we have a military vessel. And based on this information, and based also on the additional information that we have here on the right, so we have certain features, certain properties that are also labeled with a confidence that indicate the threat potential, like the direction, the speed, the range, but also the class. Of course, if this object is approaching me, but it's not a military vessel, then there is no real threat, actually. It could be a collision, but then I just change my direction and everything will be fine. This is, of course, the more harmful potential situation where we have a military vessel directly approaching us. It could be like that it tries to attack us. So this is like a highly relevant situation. And actually, by providing this kind of visualization, the user can then decide what to do, because he, as a human in the loop, has the chance to observe the object and to get some information about what the AI thinks, to then make the best decision. Actually, in this case, it is a civil fishing, it is a civil boat in the story of the paper, actually. But the interesting part here is that you may think that now, okay, well, this is like a realistic use case. Actually, yes, because what we then discuss in this technical point of view is that coming from this use case and providing to a trained AI system, so we really trained an AI system on a certain data set for vessels and for boats. And the interesting aspect here is, if we provide an image now to this trained AI system of a whaling boat, this is a quite difficult situation for the AI. Why? Because it is what is called in machine learning and AI an out of distribution example. Because the AI system it might have seen millions of training examples, but a whaling boat is a very exotic example of a boat, and we do only have very few items of whaling boats out in the world. So it's quite likely that the AI system has never seen a whaling boat before. And the interesting aspect now is, if we now have this trained AI method, an object classification approach, and we use explainable AI, as shown in this example before, in this toy example on the previous slide, we can see that this is actually quite a realistic situation, because even this pre-trained object classification method is uncertain if this is a military vessel or a civil vessel. Why? Because here we can see with this highlighted regions of the image regions that contributed to the decision, that this kind of mast that we see up here, this made the AI system think that, okay, it's most likely a civil ship. But this whaling cannon here, which is actually not a cannon that is of harm for a submarine or something, but it is kind of an indication that it could be a military vessel. And this is a potential confusion because of this very exotic example that is kind of realistic, because we can see here the AI system is uncertain about what kind of object is it. And by showing, now we're here on the top right again, by showing this kind of visualization to the user, at the end of the day, the user, as a human in the loop, can then decide what action to take from this observation. And most important, the AI system indicates that I got some insights, but I'm still uncertain, so please help me. And this is an important aspect of applying ethics here, because otherwise it might have been that the user might have taken the wrong decision to maybe even like shoot on this whaling boat, for example. Second use case. Here we are now in an entirely different scenario. So we have a military camp protection scenario, and what we have here is an airborne camera a wide area motion imagery camera. This is a camera that has a very high resolution, and it's able to not only see the military camp that's indicated here with this region here, but also a big surrounding area of this military camp. This is good because in this way, potential threats can be observed and detected quite early before they approach the military camp. And what we see here now are examples of a top-down view from this camera. And what we're using here is we use this camera to detect motion, to detect tracks, and to detect objects. And if we detect a threat, the idea is that other sensors, other cameras in that case, that are mounted on the ground, are able then to use this information that comes from this wide area motion imagery camera and to gain more information, to get directed, controlled, to observe the same object in order to get another perspective, in order to get more information, and to, in this way, to support with this automated workflow the user to make a good decision here. So what is happening here in this use case? So as I mentioned, we have this military camp here, and we have like protection areas that are indicated with this green color. And what we can see is that objects are moving inside this protected or restricted area. Actually, two events happen at the same time, which makes the scenario become a bit more complex and difficult to oversee for the human user. At this point in time, the information that he can get from the AI-assisted system is that here, this is a group of people with these tracks indicated in this orange-like color, approaching the military camp from this side. And on the other hand, we have a fast-moving vehicle on the road that is also kind of approaching the military camp. Both things happen at the same time. So we have, in the sake for transparency, we have again some kind of indication of what features contributed to this quite high threat confidence that we detect here, what kind of objects, in that case humans, what direction, the spatial proximity to the military camp, velocity, and those things are all combined to then derive this quite high threat confidence here. And we have a quite high threat confidence for both events that are happening at the same time. So the system mentions that, okay, security guards are alerted to get ready at this point in time. At this point, because of the spatial proximity of the humans is getting closer to the military camp, the focus is put a bit more on this event here, and the recommendation of the AI system is that I can observe the tracks, but I cannot really say what kind of object, what kind of object or what kind of behavior, what kind of intention we can see here. So this is why he recommends to take an action, which means that, as I mentioned earlier, we use a ground-based camera, a pan-tilt zoom camera that we can use to direct it on the objects and to get more information by taking pictures from less distance and from a side view and from a top view. But at the same time, also we have this other event still going on and still raising the threat potential here is still climbing up. So what then happens is that by using these ground-based cameras, we can have a look at both events at the same time, different cameras that are mounted around the military camp. And what we can see here is that on the right hand, we have this group of humans, of individuals, and by using this ground-based camera, we can get a better view towards the scene. And what we can see then is automatically we can detect that it's a group of children just playing, so it's kind of an accident. And the standard operating procedures, which is like the guideline for the user, for the soldier to act, then is to do some kind of soft intervention by calling the police and guiding them out of the restricted zone, which is a nice example, I think, for proportionality, as I mentioned earlier. And on the left, we can see a real threat that is then confirmed by this ground-based camera because we have a fast pickup vehicle that is driving with a high velocity towards the military camp, and it's equipped even with a gun. So we can see that, okay, there is a threat, and the guards are informed to intercept the vehicle. And also for providing a way of traceability, of governability, but also of responsibility, we always have, as a user, to acknowledge those recommendations to make sure that the human in the loop is still the last instance of decision. Okay, third use case Now we are in an even more complex scenario. We are on a land-based reconnaissance scenario in an inhabited area, a city. And what we have here is we have an AI assistant system that more generically provides sensor data analysis and fusion, operational planning, resource management. So as you can see, use case by use case, the systems become more powerful. And while the first two use cases are quite close, or we probably can do it nowadays with the technical, with the state of the art in computer vision, for example, it should be possible to automate these tasks nowadays. But this is like a bit more a look into the future. But still, I mean, since we now all know that large language models have become a fantastic, fantastic technology to help us acting and interacting with systems in a human-like way. They are nowadays used as chatbots, for example, as we all know from ChatGPT, for example. We can also use them as human-machine interfaces. This is what the new perspective that we want to bring into this third use case. So before we just had like standard edge AI methods that are implemented into the cameras and that detect objects and track objects and stuff like that. But here we want to become a bit more interactive. So we have this AI assistant that acts as a chatbot for the user and supports him in his reconnaissance operation. But still, we have again this high level of automation, considering enforces the human loop, as this was also the case in previous use cases. We have parallel tasks, which makes it more complex, and we are doing kind of information fusion, as we also did before, by considering standard operating procedures, as we saw in the example before, and rules of engagement. Rules of engagement and standard operating procedures are, as I mentioned earlier, guidelines that help the soldiers to understand what they have to do in which situation in order to act responsibly and in an ethical manner. Okay, let's go and have a look at the use case. So what happens here? We see an enemy convoy, actually a group of main battle tanks. This is also indicated here. We detect that automatically, and we have like the confidence of the detection here. So we have high confidence, so we can be quite sure that the AI system is certain about what it sees here, which is main battle tanks approaching. And they are actually approaching from a demilitarized zone, which is this area here, and they are heading right towards our own territory, our friendly territory. So they are intruders in this way. So as a user, I get informed by the AI assistant, by the chatbot, that there's a group of enemy vehicles about to leave the demilitarized zone here and about to move into my territory here. That's why the threat level is increased. At the same time, the second assistant pops up that informs me about a second event that is happening in another region of the same area that I observe here. There is an infantry fighting vehicle that also has crossed this river that is actually the border between my territory and the demilitarized zone. It's a hostile vehicle, and it stopped right next to a building. The AI system, it informs me that this vehicle has stopped at a building, and by using additional data sources, like for example OpenStreetMap, for example, it can identify this building as a school. So when I now as a user ask, is this enemy vehicle an eligible target? The AI system says no. There is a standard operating procedure conflict that says that children are specifically protected. So we have to assume that maybe children could be present in the school. So if we now shoot at this vehicle, then it can happen that we also are injuring children that are still inside the school, for example. Which is one example of applied ethics, actually. At the same time, we have this other event that is where still things are going on. So we now see that these main battle tanks are crossing a bridge and approaching our territory. So again, here, the AI assistant system is informing us about this event taking place. And we again ask, as a user, is the enemy group an eligible target? And here, the AI system again says, no, it's actually on a protected infrastructure, a bridge, and we should not shoot on this group of hostile vehicles because we could destroy the bridge, which is not something that we would like to do. So it's also mentioned that it's an eligible target, the group of vehicles, after reaching a certain coordinate. We again go back to the other assistant that informs us about specific movement next to this vehicle that is close to the school. And the AI assistant system also mentioned that it's not able to see what directly happens there, so it recommends to send an unmanned aerial vehicle to gain more insight, which means, like in this case, this AI assistant system also provides some kind of sensor resource management or resource management in general by suggesting, hey, send a camera mounted on a unmanned aerial vehicle to this location to get some more insight on what's exactly happening there. We go back to this first scenario. Now these main battle tanks, they moved further into our territory, and the AI assistant system then informs us as soon as this happens that now this enemy group is an eligible target, and we could now say, okay, now we need to take an action. We need to do some counter. We need to use some countermeasures here. The UAV at the same time went to this other place with this infantry fighting vehicle and was observing a scene like this, where we could see that it seems that injured and wounded soldiers that other soldiers are taking care of them. Still, they are hostile soldiers, but the rule of a certain rule of engagement tells us that wounded soldiers are protected. So still, this vehicle and the humans are no eligible target. I will summarize my talk here now. So what I presented is 3 different scenarios that we discussed in our white paper. One is coming from maritime surveillance, where we used explainable AI technology to help us better understand a situation in which the AI system is uncertain about what's happening and it's uncertain about what to recommend. It makes it transparent and the user is able to react on that, while the AI system provides all the information that it gained so far to support the human in his decision. The second scenario with military camp protection, we were able to see collaborative sensors, cameras, and motion analysis to help the operator gaining more insight and information over time, and by this to distinguish between real threats and non-threats, even in complex scenarios where 2 events are happening at the same time. And the third scenario, I was presenting a land-based reconnaissance scenario in an inhabited area where we use large language models as a chatbot that assists the human operator and that implicitly fuses information such as rules of engagement or standard operating procedures with just gained reconnaissance data to consider ethical aspects for decision making, as we were able to see in this chat window here. Okay, with that, I want to again advertise our white paper that we published earlier this year. If you want to get some more details, want some more information, or more technical point of view, or whatever, or the application of the ethical principles that I just was able to discuss a bit here, have a look at the paper and feel free to contact me in case you have any questions or ask them now. Thank you very much.
Thank you so much, Michael. And now the discussion is open. If you could take your slide off, please, so that we can see the audience.
Yep. Now I stopped sharing the slides.
First question, Alipio. Go forward, please.
Yes, so thank you, Michael, for the great talk. Thank you for coming here and sharing all this very close to the ground knowledge about AI and defense. So a technical question, how do you evaluate the explainable capabilities of the solutions that you have, assuming that you already use these kind of technologies in some of your solutions?
We are preparing to use such technology, yes. It's not directly deployed yet, but we're working on that. And if I understood your question correctly, you're asking about like how can we assess the quality of explainable AI methods, yeah?
Yes.
Yeah, exactly. I was referring to a paper earlier where we also took this object classification approach from. And in this paper, we specifically focused on analyzing not only object classification methods, but also explainable AI methods. So what we can do there is, it's called, I just forgot the term, but the idea is to, you want to assess the quality of an explainable AI method quantitatively. So you want to have a measure that tells you how good is it working. And the idea is, how you do that is, you have the heat map, and you start erasing pixels that are marked as red, that are most relevant for the classifier. Yeah. And when you start erasing them, you again, after you erase some pixels, you run the classifier. And then you want to understand if the classifier now lost confidence in this classification decision. And you do this incrementally. So you delete more and more pixels from the most relevant pixels, yeah? And then you want to see a sharp drop in confidence of the object classifier. Because this means that in this way, we were really able to erase the most important pixels. And this also gives us an indication that the explainable AI method really highlighted the most relevant regions for the object classification approach. Does this make sense?
Yes, sure. So that's the evaluation, very important evaluation with the sort of the validation data. But how do you evaluate this on the ground with humans? So this is going to be used by humans, and how do you do that? So any kind of surveys, or how would you do that? So you're not doing it yet, but what's your planning for that kind of evaluation on the ground?
True. Okay, good point. And by the way, it's called deletion game. I remember this method. You can find in the literature. It's called deletion game, where you start deleting pixels, and you want to see this sharp drop in confidence to verify that you got the right pixels to delete, and this is a good explainable AI method. You're talking about now about the second use case with these children playing and stuff like that. So what we usually do here is we did not use an explainable AI method here. What we did is we use methods for behavior analysis. So the idea is that by analyzing the track information that we got, and by also using the appearance information that we can get from the camera, from the image, we can distinguish between children and adults, for example. And we can also distinguish between playing or digging or fighting or other actions that we can categorize. So that's the idea here. We do not use explainable AI methods here yet, at least not in this example, but also on these kind of higher level features, we could call them. Before we were talking about low level features like pixels and stuff. Here we are talking about higher level features like tracks, like behavior and so on. There are some explainable AI methods out there to also verify that the meaningfulness of these features that we used. And we're also using them in different other applications, but this specific method is not part of the white paper. So I'm kind of deviating here from the presentation. But there are methods out there to verify that the behavior analysis and the track analysis, the motion analysis was focusing on the correct features when, for example, telling us that those are just playing children, for example.
Thank you.
Mm-hmm.
I have a question myself. Are those systems interactive? I mean, after you got these first results, can you ask for details or for particular analysis on this or that aspect that could enlighten you more before a decision? Or is it just one shot? How does it work?
Can you please rephrase again? I'm not sure if I understood the question correctly. Sorry for that.
After human gets results, can the human request some further analysis or inspection or details that can enlighten this or that aspect?
Yes, of course. So the idea is that at each point in the analysis, the human can maybe just like ask for more insight, for more analysis. And even like in the examples that I showed, we had some kind of workflow indicated by buttons and so on that tell us like, okay, I now acknowledge that I understood what you were what you were suggesting or recommending, and that I accept your recommendation, for example. And in this way, we enforce this kind of human interaction. And specifically, of course, if a human may not be certain about if he should acknowledge or not, then the idea would be, by good user interface design and good workflow design, to then assist the user in gaining more information if he needs it, for example, or to trigger further analysis, for example.
Sense? Sense? Ken?
Yes, I'm here. I have a question for Michael. Michael, could you summarize the adaptation method used? Specifically, how do techniques like fine-tuning or RAG allow the model to handle the ambiguity of rules of engagement and also the standard operational procedures to provide ethically sound guidance?
Right. Yes, exactly. So you point out the right technology that we use here. So in addition to the large language model, of course, we use a retrieval augmented generation, RAG, approach to contextualize the large language model with the relevant information that we want the LLM to consider, which means that we want to feed the standard operating procedures and the rules of engagement that are usually provided as a list of rules in a PDF, for example. We want to feed it as context to the large language model. How can you do that? You can do it with a naive RAG, that you just generate a vector database of chunks of the text. And then in RAG, you try for a certain query or prompt, you try to find the most matching examples in the vector database and provide it as additional information with a prompt to the large language model. This is how we would do it naively. However, what we also see is that, and this is also a direction that the literature currently takes, that if we are pre-structuring the knowledge in kind of an ontology, for example, a knowledge graph, this usually can help the large language model to easier and faster access the correct information, and also to avoid any kind of hallucination. Because what we then do is basically we have all the information, the relevant information, structured in a knowledge graph, and we use the large language model as a translator. So it translates the human speech to a data query, for example. We use, for example, Sparkle as a query language for knowledge graphs. And then you can just pick the relevant data from this ontology, from the knowledge graph. And then you translate it back in human language to give the answer as a chatbot. So this is a great method that you can use, for example, graph RAG, then in that case, as a more advanced and sophisticated method of RAG to then really access the information that you need. And this is a very feasible way, I have to say, in using large language model and making them reliable and robust. It works quite well, and we are working on that. And we even now having a project together with another Fraunhofer Institute, where we work on automatically structuring rules of engagement and standard operating procedures in a way that a large language model can access them reliably.
Michael, just to clarify, sorry, but have you tried the continual pre-training adaptation for the base model LLM?
Not so far. What we did is our principle so far was that we want to use the large language model as it comes, because we want to avoid any kind of fine-tuning, to avoid any kind of catastrophic forgetting or whatever you can do. You can do many things wrong when you do retraining or fine-tuning of a large language model. That's why we try to avoid it as long as possible. And RAG technology gives us a fantastic way of mitigating that, because we can contextualize, and we can leave the model as it is, but we can contextualize it with this vector database and with this ontology that we provide. This works well. This works really fine. And as long as we are sufficiently satisfied with the results, currently we are, we will follow this principle, because it helps us to use large language models as a commodity. We do not need to train them by ourselves, because it's quite difficult to do the right thing.
Okay, thank you.
Nelson, would you like?
Thank you. Michael, did you, in your experience and study, tackled or thought about how adversarial examples can be used to influence the decision-making process of AI, and how can this influence at the end the decision of the human in the loop?
Yes, of course. that's a typical way of fooling neural networks. We can see many articles in the media and in the papers where, for example, a specific noise pattern, for example, is added on an image. And then the AI system is detecting a different object and is fooled in this way. And we can also see those are, I mean, those are not super relevant, we have to say, for at least we do not consider them as so relevant, because on the one hand, to provide good adversarial attacks as an attacker, you have to have insight into the training process of the neural networks. Yeah. And obviously, we do not provide access and information and insight into the training of our neural networks. And we are also using data augmentation techniques that help us to become robust against adversarial attacks. However, more interested, like adding noise patterns by ourselves into a training and stuff to become robust. More interesting, actually, at least in my point of view, are physical adversarial attacks. Mm-hmm. Physical adversarial attacks happen when you have, for example, a sticker with a certain pattern, and you put it somewhere. Maybe there was a nice example, I think, in an automotive scenario where there's a stop sign and you have the sticker, and then the AI system is detecting something entirely different, not a stop sign anymore. This is, of course, highly safety critical, and thus it's really relevant. And also, we have seen similar publications trying to find good kind of stickers or kind of camouflage patterns that help tanks camouflaging themselves, not in a typical way with these greenish colors, but with the specific patterns to fool AI systems. This is more relevant, I think, because they are generically applicable, and you do not have to have this insight into the training process of the AI method. But they're quite challenging also, because you have to be able, when you design such a sticker, you have to be able to be robust against different camera perspectives, for example, distances of the camera to the object, and so on. And I do not know of a generic method to provide such kind of camouflage. I think that it can happen, it can be the case, but I think we're not there yet. However, we are observing that carefully to be prepared as soon as we observe methods that work, and to make our, let's say, to enrich, for example, our training data, to make the AI system become robust against such measures as well.
Thank you.
You're welcome.
Still another question, Michael. The examples you have shown are all of them based on images. We use the same type of procedures to scan communications, for instance, or to try to devise some hidden messages in communications, oral or written, or?
Yes, we are doing that. The reason why we focused more on imagery in this study is that on the one hand, it's fantastic to present it. You can show pictures, and this is like the most intuitive thing to see for humans. And on the other hand, I'm coming from the field of computer vision. So I have been a computer vision researcher for 15 years now, I think. So obviously, for me, it was more intuitive to work here in this vision domain. That's why we focused a bit more on vision here. But we are doing similar studies with electronic warfare, signal intelligence, communications intelligence data, with natural language processing, and with radar data as well. Yes.
I don't see any hands up. Well, if there are no more questions, I'll close the session. But first, by saying thank you so much. It was an incredibly interesting talk that you have given us. As I told you before, very to the point of our interests in this series of talks. And Terry, thank you very much for your availability and for being with us this about an hour that we have been together. Thank you very much.
Thank you very much for hosting me. And you can easily find me in LinkedIn if you like. So just drop me a line if you want to have access to the paper, for example, or if you want to have any further information or questions. Feel free to reach out. I'm looking forward. Thank you very much.
Thank you very much.
Have a great evening.
Bye. Bye.